We're going to continue with the quadratic formula. Again, you're going to need to memorize this for the test. I'm not going to have it on the test when we get around to it. Yeah, so what we're going to explore is the graphs of some of these and being able to answer, I guess, a few more applications to the quadratic formula. But anyway, as you recall, finding the x-intercepts using the quadratic formula, we would use x equals negative b, so positive 4 because it's negating that, plus or minus the square root of b squared, so negative 4 squared is 16, minus 4 times a times negative, so 4 times 1 times c, so times negative 36, all over 2a. So kind of as a heads up, if you're allowed to use a calculator, you want to do everything under the radical first. So 16 minus 4 times 1 times negative 36 to get you 160. And I would encourage you just to do the scratch work off to the side, that you could break that down as 16 and 10, and then 4 and 4. Now you could break down 10, but there's no other pairs. So we're looking at x-intercepts of 4 plus or minus 4 root 10 all over 2. But in simplest radical form, I need you to divide all those whole numbers by 2. So we're looking at 2 plus or minus 2 root 10. So that's just simplest radical form. That's not very helpful for us unless we know what those numbers actually represent. So that's what I meant by I knew we were going to use a calculator if we were talking about a graph. But if we type into our calculator, we can only get one answer at a time. But what I like is you can go up and grab that equation, that expression I should say, and change that plus to a minus, and you can see both x-intercepts at 8.32, well, it says nearest hundredth. I just like the nearest thousandths, so 8.32 is good enough. And I put a squiggly for the approximate. Okay, but as we go into pre-calculus, you'll see I start rounding to the nearest thousandth. And they ask you to use your calculator to sketch the graph, and then you practice the 0 command to verify our answers. So on our graph and calculator, let me scroll up because I already forgot, x squared minus 4x minus 36. So y equals x squared minus 4x minus 36. I'm also going to sort of cheat, but it's not really cheating because they tell you how to change your window on the problem. To go, so your window, change it to be negative 20 to 20 on the x-axis, and then also negative 50 to 50. And I don't know if you notice, I hit the window key to get to this. Start changing around the numbers. Make sure you hit the negative key instead of the minus key. And when you go to the graph, you get a pretty good approximation. And a lot of other things should make sense to you. For instance, I'm just kind of lamely drawing this on here. Very lame because this should be 8 and it doesn't look like it's 8. Like this point is negative 4.32 comma 0, and this point is about 8.32 comma 0. But we could also talk about this vertex down here, and we practiced finding the vertex. We've also practiced finding the y-intercept. You know, the y-intercept is 0, negative 36. And the vertex would be, well, if we did our negative b over 2a formula, it becomes a positive 2. And then you'd have to do, like, plug in 2 squared is 4 minus 4 times 2 is 8. So I believe it goes down to negative 40. But let's actually answer this question for letter C, is to use the 0 command. So what you do is you hit second, so the blue key, and then trace, so you can calculate. And we call x-intercept zeros, so that's why we say use the 0 command. Hit enter when you're on that. And as you move your cursor to the left, notice that it says a left bound. So to the left of the x-intercept, hit enter. Move it to the right of the x-intercept, hit enter. and then somewhere in between, and it gives you the correct answer. Why do we call it a 0? Because y equals 0. But notice we get the right answer, negative 4.32. You can do the same thing with and we can only do 1 0 at a time. So that's why I have to do it twice. So second, trace the second option. You can even hit the number 2 when you're on there. Move the cursor to the right now, but notice that I'm still to the left of that X-intercept and hit enter. Move the cursor to the right, anywhere to the right of the X-intercept, hit enter a second time, and then pretty close to the X-intercept, and it gives you the correct answer, 8.32. Yeah, I think I already did all of that. So which of the following represents the X-intercept on this one? Well, we have to use the quadratic formula. Now, here's the thing, is we might not have to use the quadratic formula. If you look, we have rational answers here. But let's practice using the quadratic formula. I'm pretty sure it's one of those rational answers. But anyway, x equals negative b plus or minus the square root of b squared. Now notice that I like to drop the negative when I square, because whether you square a positive or a negative, you're going to get a positive answer there. So 4 times 3 times 6 all over 2a, so 2 times 3. That's a quadratic formula. If you're not understanding anything or if something seems like magic, please bring your question to class. So as I mentioned before, if you're given the calculator, go ahead and do everything that's under the radical first. That's the square root. So that's 289, and I don't know if you know this, but the square root of 289 is actually 17. So the best answer would be a 19 plus 17 all over 6, 2 times 3. But then also, I'm going to put a comma, 19 minus 17 all over 6. And again, you can use a calculator. If you're not good at doing 19 plus 17, it does come out to be a very nice number, all over 6. And then I can go up and just grab that equation and change that plus to a minus. There you go. 6 1/3, 6 1/3. So I do realize there are other ways of answering this question, but anytime we're asking for the X-intercepts, we are doing the zeros. So here's another problem. Crazy Caramel Corn Company. We have a percentage of popcorn kernels that pop with the temperature, yada, yada, yada. And what they're asking you to do is write the range of temperatures that ensure at least 50% of the kernels will pop. So how can we set that up? And it's been a while since we've actually done these types of problems. I feel like it's been a while. So I'm just rewriting the equation, and P stands for the percentage. And when I see the word at least, I'm thinking 50, that's the number right here, or more. So that's, to me, a greater than or equal to. And so you might see phrases, other phrases to look out for would be things like at most, or more than, less than, but that's how I would set this up. So at this point, what I would say is let's compare this to 0. Well, how can I get that 50 to the other side? I could subtract the 50 over. And just the quick arithmetic in my head, negative 1 over 250, still t squared, plus 2.8t. That would be 444. It's greater than or equal to 0. Now, if we employ the quadratic formula, we're going to have negative b plus or minus the square root of b squared, so 2.8 squared, minus 4 times a times c, all over 2a. So what I would actually do is just go to my graphing calculator, and how earlier I mentioned your calculator can only do one problem at a time. That's okay. we'll just do the plus first and see what kind of answer we get. And I'm okay doing this because the directions don't ask you to write the answer as simplest radical form. I don't know if you noticed that. It just says to round your final answer. And hopefully I typed everything in correctly. And as I hit enter, this tells me I need a temperature of 242.8 degrees, or 76 if you round correctly. But that might not be the only answer, because I need to go up and change that plus to a minus 457.238 degrees. So let's actually understand what kind of graph we're looking at. So before committing to an answer, think about how this is a negative a value. So what that tells me, I don't know exactly what this graph looks like, but it goes up and then comes back down. If we consider y equals 50, that's what this is right here, y equals 50, we have this range of numbers, range of temperatures that get us at least 50% of the kernels that pop. So if I go back to my calculator, does it make sense that we want answers between 242.76 degrees less than or equal to T, or less than or equal to 457.24? And that's the kind of answer that we're looking for. And then one more, I guess, word problem is using algebra to be able to find points of intersection. And then I can quickly graph this and see what the final answer is. But anyway, the algebra is setting the two equations equal to each other. So what I would do is compare this to 0, just like I did the previous problem. So I have to subtract 6x over. I also need to add 3 over to cancel those things out to get it equal to 0. So we have 4x squared minus 12x plus 5. And I'm not quite sure if they're going to cross, if this is going to be factorable. So let's practice the quadratic formula. X equals negative b plus or minus the square root of b squared. 12 squared is 144 minus 4 times a times c. So this 4 was from this 4, this 5 was from this 5, all over 2a. So again, if we want our answer in simplest radical form, I don't even know if I'm... Anyway, let's look at simplest radical form. What you want to do is what's under the radical first. And maybe you don't know that 12 squared is 144, so you could type in 12 squared minus 4 times 4 times 5. All right, that's 64, but then you need to square root that. Sorry, I hit the wrong button. So we have 8. So our answers are going to be 12 plus 8 divided by 8, 2 times 4, but also 12 minus 8 divided by 4. And if you simplify that, you get 20 divided by 8, and they're both divisible by 4. You get 5 halves. And then also, oops, I kind of got ahead of myself. 12 minus 8 is 4 divided by 8 reduces to 1 half. But what does our answer actually mean is I can go to my graphing calculator and go to y equals and just type in the equations. Wait, 4, I gotta hurry to get this video done. Minus 6x plus 2, and then 6x minus 3. I'm also going to change my window the way it says on the problem. It goes from negative 5 to positive 5, and then negative 5 to 15, if I remember correctly. And you can actually see that they cross at 1 half and 5 halves. And I'm going to kind of cheat and just sort of slide this on here. for my final answer.